Kevin, Garnet, and Bedron from BSN 1B. Today I'm going to talk about the Table 4.6 Classification of Connective Tissue, Table 4.7 Embryonic Connective Tissue, Table 4.8 Connective Tissue Proper, which is the loose connective tissue, Table 4.9 Connective Tissue Proper, which consists of dense connective tissue and dense connective tissue continuum. Classification of connective tissue. Connective tissue types blend into one another and transition points cannot be identified precisely. As a result, connective tissue is somewhat arbitrarily classified by the type and proportion of cells and extracellular matrix components. Table 4.6 is the classification of connective tissue. There are two major categories of connective tissue, which is the embryonic connective tissue and the adult connective tissue. Embryonic connective tissue consists of mesenchyme and the mucous connective tissue. Adult connective tissue consists of connective tissue proper. Under connective tissue proper, there is the loose connective tissue proper and the dense connective tissue proper. The loose connective tissue proper has fewer fibers but have more ground substance, while the dense connective tissue proper has more fiber but less ground substance. Under loose connective tissue proper is the areolar, adipose, and reticular, while the dense has the dense irregular collagenous, dense irregular elastic, dense irregular collagenous, and dense irregular elastic. Supporting connective tissue consists of cartilage or semi-solid matrix and bone solid matrix. Under cartilage is the hyaline, fibrocartilage, and elastic, while bone has spongy and compact, while fluid connective tissue has blood and hemophoetic tissue. Under blood is the red blood cells, white blood cells, and platelets. Hemophoetic tissue has red marrow and yellow marrow. Let's proceed to table 4.7, which is the embryonic connective tissue. Earlier, mesenchyme was under embryonic connective tissue. So this tissue is called mesenchyme. It is composed of irregularly shaped fibroblasts surrounded by abundant semi-fluid extracellular matrix in which delicate collagen fibers are distributed. It is formed in the embryo during the 3rd and 4th weeks of development from mesoderm and neural crest cells, and all adult connective tissue types develop from it. By 8 weeks of development, most of the mesenchyme has become specialized to form the types of connective tissue seen in adults, as well as muscle, blood vessels, and other tissues. Here is an image of a mesenchyme. The mesenchymal cells are irregular shaped, the extracellular matrix is abundant and contains scattered reticular fibers. It is located in the embryonic tissue from which connective tissues as well as other tissues arise. Next is the mucous connective tissue. The major source of remaining embryonic connective tissue in the newborn is in the umbilical cord, where it is called the mucous connective tissue or the Wharton's jelly. The structure of the mucous connective tissue is similar to that of a mesenchyme. The mucous connective tissue helps to support the umbilical cord blood vessels between the mother and the child. After birth, the mucous connective tissue can also be a rich source of stem cells. Here's an image of a mucous connective tissue. The mucous tissue is mesenchymal tissue that remains unspecialized. The cells are irregular shaped. The extracellular matrix is abundant and contains scattered reticular fibers. It is located at the umbilical cord of a newborn. Next is the adult connective tissue. This tissue consists of 3 types, which is the connective tissue proper, or the loose and the dense, supporting connective tissue, which is the cartilage and the bone, and fluid connective tissue, which is the blood. Table 4.8 is the connective tissue proper, loose connective tissue. The first of the loose connective tissue is the areolar connective tissue. This tissue is the loose packing material of most organs and other tissue. It is attached to the skin to underlying tissues and contains collagen, reticular, and elastic fibers and a variety of cells. Here's an image of an areolar connective tissue. Its structure is cells within a fine network of mostly collagen fibers, often merges with the denser connective tissue. Its function is to loose packing support and nourishment for the structures within
which it is associated. It is located at the epithelial basement membrane rest, packing between glands, muscles, and nerves, attaches to the skin to underlying tissues.
Next is the adipose tissue. It is consists of adipocytes which contains large amounts of lipids or fats. Unlike the other connective tissue types, adipose tissue is composed of large cells and a small amount of extracellular matrix which is consists of loosely arranged collagen and reticular fibers with some scattered elastic fibers.
Here is an image of an adipose tissue. Its structure is a little extracellular matrix surrounding cells. The adipocytes are full of lipids or fats that the cytoplasm is pushed to the periphery of the cell. Its function is packing material, thermal insulation, energy storage, and protection of organs against injury from being bumped or jarred. It is located in subcutaneous areas in the mesenteries, in renal pelvis, around kidneys, attached to the surface of the colon, and mammary glands in loose connective tissue that penetrates spaces and crevices.
Next is the reticular tissue. This tissue forms the framework of lymphatic tissue such as the spleen and the lymph nodes, as well in the bone marrow and the liver. It is characterized by a network of reticular fibers and reticular cells. Reticular cells produce the reticular fibers and remain closely attached to them.
Here's an image of a reticular tissue. Its structure is a fine network of reticular fibers irregularly arranged. Its main function is to provide a superstructure for lymphatic and hematopoietic tissues. It is located within the lymph nodes, spleen, and bone marrow.
Next is the table 4.9. It is the connective tissue proper, which is the dense connective tissue. The first dense tissue is the dense regular collagenous connective tissue. This tissue has an abundant collagen fibers which give this tissue a white appearance, and this tissue forms structures such as tendons which connect muscles to bones and most ligaments which connects the bones to bone.
Here is an image of a dense regular collagenous connective tissue. Its structure is a matrix composed of collagen fibers running in somewhat the same direction. Its main function is to able to withstand great pulling forces exerted in directions of fiber orientation, great tensile strength, and stretch resistance. It is located in the tendons or attached to the muscle to the bone, and ligaments attach bones to each other.
Next is the dense regular elastic connective tissue. Dense regular elastic connective tissue contains elastin fibers in addition to collagen fibers, which allows the ligament to return to its original length after stretching. The ligaments in the vocal folds and between the vertebrae in the vertebral column are elastic.
Here is an image of a dense regular elastic connective tissue. Its structure is a matrix composed of regularly arranged collagen fibers and elastic fibers. Its main function is to able to stretch and recoil like a rubber band with strength in the direction of fiber orientation. Its location is in the vocal folds and elastic ligaments between the vertebrae and along the dorsal aspect of the neck.
Next is the table 4.9, which is the continuation of dense connective tissue. The third dense connective tissue is the dense irregular collagenous connective tissue. This tissue forms most of the dermis, which is the tough inner portion of the skin, as well as the connective tissue capsules that surround organs such as the kidney and spleen.
Here's an image of a dense irregular collagenous connective tissue. Its structure is a matrix composed of collagen fibers that run in all directions or in alternating planes of fibers oriented in a somewhat single direction. Its main function is tensile strength capable of withstanding stretching in all directions. It is located most of the dermis of the skin, organ, capsules, and septa, outer covering of the body tube.
Next is the dense irregular elastic connective tissue. This tissue is found in the walls of elastic arteries. In addition to collagen fibers oriented in many directions, the layers of this tissue contain abundant elastic fibers.
Here's an image of a dense irregular elastic connective tissue. Its structure is a matrix composed of bundles and sheets of collagenous and elastic fibers oriented in multiple directions. Its main function is capable of strength of the stretching and recoil in several directions. It is located in the elastic artery.
Okay, that sums up my report about table 4.6, 4.7, 4.8, and 4.9, which is the classification of connective tissue, embryonic connective tissue proper, loose connective tissue proper, dense connective tissue, and its continuation.